Hello everyone, welcome back. My name is Rafael Scala. Thank you for watching this video. Today we will continue doing a video series talking about the design data intensive application book. This is the early access, the 2026 edition. And today we have a case study to do a small system design. In this case, a social network, the Twitter, a social network, or call it X, right? And this video it will handle it like trying to do a simple solution at the first time rather than jumping directly to the complex technology, because the idea to this video is to understand what is the intuition, right, or the reason that is to the reason that you need to implement this complex solution. I mean, if we started with relation database and trying to resolve it with a simple way, you will face multiple challenges. So the idea is understand what challenge you will have when you trying to cover a capacity planning. So that is the idea of this video. Okay, so we will start with a functional requirement to complete this system design. Okay, and the functional requirement is all the requirement that you have to complete to release this application for the users phase, right? So this is the features. Okay, so in this case we have an support social network that you can post multiple message, right? I mean post, right? User can follow other users. Yeah, okay. And user have a home timeline that have to be updated according to post that this user have as a followers, right? Or following, I mean, sorry. And the no functional requirement is the part that the software solution that had to cover to complete this functional requirement. I mean, it's obviously that your solution had to be have a good performance, reliable, and scalable. But it's important to take note that because when you are trying to assume and doing the capacity planning, you have to implement these non-functional requirements. Okay, that is the idea. So the first thing that we have to start is some assumptions, right? To understand what will be the challenge. In this case, is we will assume that there are 500 millions of posts per day. That is the same thing to say that there will be 5,800 posts per seconds. Okay, and this is only a regular or an average of the day. But you have to know that in the average day, there will be business hours, and in some moment you could have a spike of post generation, and obviously the traffic it will be growing, right? So in this case, we assume that when there is a spike of the post generation, there will be 150 thousand of posts per second. And the average that maybe a user could follows is 200 of users. Okay, and the celebrities of this social network will have 100 of millions followers. So that is some assumptions. Okay, so um, the first thing that maybe you can take a note if you don't create something complex like a graph database is create a relation database. Okay, so um, continue this trying to do something simple, right, is to create three tables in this case. Maybe a table to have the relationship between the follower with the followee, right, and the list of the post for each user, right? And the table of the user in this case, okay? So that is the idea in summary. It's very simple. The idea is to see what will be the challenge, okay? So, okay. Okay, this is the home timeline query that we would use it to show the list of the posts of each home timeline, okay? And the first thing that we can see is I trying to get a list of the posts, and for each post, the idea is to get the following user ID. We have to match with the following user ID because the following user ID created this post, and the details of the user And finally, using the table follows, we have to match the user that is following this user creator, right? Had to be order, right, with the timestamp and limit, in this case, like an example, 1000 of posts, okay? So that is the idea in general that we will build the main logic, okay? So continue doing the API design or the logic that will be covered to finally show the home timeline. And the first thing maybe is to try to do super simple. So in this case, before talking about the WebSocket, we will try to resolve only using pooling, because the idea is to see what challenge we have to cover if we're trying to do a pooling. Pooling is when you have like a ping, usually calling to the server to notify that if there is a new post, right, at the moment of the user that is trying to see the home timeline. So in this case is that you can set an interval of how many times you want to call this pooling in a range of that time. I mean, for example, you want to get or verify or synchronize if there is a new post for each 5 seconds. So that the interval is just 5 seconds to get this list of the posts updated. Okay, we have to take a note. Okay, in this case, for example, we get a list of the home timeline of this user. Then we will call the query that I showed before. It will return 20 tweets, right? And you have to take a note that it's a slow query, like we see before. Uh, we will explain later, but okay. Continue with this, and you have to wait 5 seconds and repeat the same loop. Okay, so that is the idea in general. But so the first challenge that maybe you can see if you were trying to resolve this with pooling service is that what happens if there are 10 millions of users connected in real time, and if we're talking about that there will be an interval of 5 seconds, that means that there will be 10 millions of requests for each 5 seconds. And per seconds means that will be 2 millions of requests. Okay, so take a note of that. And what happens if there for each user, the user will have it will follow 200 users. That means that in the site of database, there will be trying to read, okay, we're trying to see that there will be 2 million of users, 2 millions of requests. And for each request, need to get the list of the posts because there is an index, right, that you have to get a list of the posts for each user. And that means that there will be individual fetch for for 200 user for each request. So in this case, we're talking about that there will be, in this case, 400 millions of post fetch that we can handle it in the database looks up. So that is that is super heavy way to handle it, the home timeline query, right? Because we are talking about that to write something, to write an post is cheapest, because actually you only to take care the list of the posts of each user that is connected in that moment. But the problem is the pooling, because for the pooling have to fetch individually the list of the posts that this user is following at that moment. So in this case, we're talking about the workload or the heavy load. It will be in the side of the read in the side of the read. Okay, so that's me. Okay, so how we can resolve this problem is so the first thing is how we can resolve this issue. Okay, so to improve this, maybe we can inverse this balance to, instead to have the heavy load in the part of the read, we can move it in the part of the write. So using a batch processing to handle this expensive query, right? and leave the part of the user experience with a cache to be to not affect the experience when trying to see the latest post that is prepared for their home timeline. Okay, and leave the part of generation the timeline like an asynchronous process. Okay, so we have this new system design. Okay, we have to assume that there are two users here, the Alice and Bob, right? That is the follower, and the Alice is the person that is create a post. In this case, there will be a post, okay, and there will be a process, right? A process that it will handle it asynchronous, right? First, it will insert a tweet on the database that Alice can see the post created, but to update the home timelines for the rest of the user that is following this Alice user, it will handle it with a sub process. That is, in this case, this find out process. That is the correct. That is the term when we are trying to say that there will be a spread and updating in multiples user cache. Okay, so that means a fan out process. Okay, so there will be an updating of this list of the home timelines asynchronous, right? And eventually there will be a notification, push notification with WebSocket to not have to have this pooling problem, because Orwell is trying to verify if there is a new updating. So we're trying to remove the part of multiple requests, and only in this case, the server will notify when the user needs to be updated. So in this case, when the fan out process for a single user is completed, there will be a push notification, and the user, in this case Bob, it will update the timeline that already is prepared in this cache layer, right? So uh, that's the idea, is to inverse the responsibility in the part of the write instead to be on the read side. Okay, but obviously in this case there will be some challenge that you have to take. Okay, so if we assume that there are 5,000 of posts per second with an average of 200 followers, take a note that we have to write these home timelines asynchronous. And that means that if there are 5,000 posts for each, and there will be 200 followers that have to be updated these home timelines in parallel or asynchronous, there will be 1 million of lines to write. But obviously, it will be better than to have this approach that 400 millions lines of fetching that you have to get the data of hometown line, right? In the pooling approach, right? So obviously it will be better this approach. And what happens when there is a post spike, when there are multiple post generation in a time, right? In a single hour. So in this case, we have to take that challenge using a message queues that it will be eventually consistency updated, right, in the multiple hometown line. But the idea is to be assuming that partially at the time all the hometown lines it will be updated and not have an overload or over workload, right, um, of the servers. So that's the idea. And what happens if the user who follow a very large number of accounts? That means the challenge is when, for example, you follow 10,000 of users, 10,000 of posts generated in that spike of time. The problem is that with a line to write, because that means that there will be 10,000 of post generation with 10,000 queues that is trying to update your home timeline. And actually, it will be a challenge when there are multiple users that follow several accounts, and, and obviously, um, take a note that a regular user not will read the 10,000 of post generation, right? So maybe you can create an example, right, or a summary of this post generation, right, and not to have to cover to notify the all post generator for all the uh, user that you are following, right? So that is the idea, to only have an example of this post generation of your following. That is a solution, okay? And what happens if you have a celebrity account that have millions of followers? The problem is that if we follow this approach, that means that you have to create millions of sub-process to notify this million of followers. Only a single celebrity it will generate the same thing that you can have in a regular day, actually. So that could be a problem. So for those cases, there is another approach here. When there isn't a celebrity, okay, we have this example. If we have two users that is generated in a post, and a single user that follow them, right? So in this case, Alice, that is a normal user, post something there, right? There will there will this post it will go to this fan out to update the timeline cache for this user Bob, right? But when the celebrity posts something, instead to do this phone out, it will be an hybrid load. It's like we will have another storage to have the all the post generation for these celebrities, right? And when the user is trying to get the hometown line, and there is a condition that if there isn't a celebrity in this list of followings of this person, right? It will merge the list of the home timeline that is prepared for this user, right, with normal user, and the list of the posts of the celebrity that is already prepared to consume. Only that. It's like you will have two buckets, right? The bucket for your timeline personality customized for you, and the bucket of the celebrity that it will be it will share for multiple users that only if there is a single following of these celebrities, right? So that is the idea. And with this approach, the idea is to have the inverse solution. Is that the main heavy load it will be on the part of the write, and the read it will be transparent or very have a good time of performance, right? And the idea of this is when there is a pre-computing and updating of this cache, it's called materialization, right? So that is a concept that I am sharing in this video. And that's all for now. Thank you for watching this video again, and see you in the next video. Okay. Take care and goodbye.